Okay, so on these explorations, we're told that these shapes have this amazing property of having the same perimeter as they do area. And then so the task is to write an expression for perimeter and then one for area, set those expressions equal to each other, and then we'll solve those equations. So one thing to note, I think you'd probably pick it up pretty quickly. So on this shape that kind of looks like the house, the left-hand side would also measure 4. So we're pretty solid there. I feel like we should be able to write the perimeter formula. So going through it really quickly, starting over on the left-hand side, we'd have a 4 plus a 5 plus another 5 plus a 4 plus an x. Right? So I might look at this and say, okay, well I have 2 4s and 2 5s, and then I have finally my length that measures x. So there's an expression for perimeter. Now area is what I wanted to talk about real quickly. So an idea would be that, okay, well the area of a rectangle is length times width. Right? So hopefully you remember that, but if not, it's okay, we can work with it. Right? Or you could look it up on the internet. So we'll consider this to be the length. Right? So we'll put an L, and we can call this the width, or we can call it the height. But the idea of finding the area of a rectangle, it's one dimension times the other dimension. So for area, I'll use red, and so I've got x times 4. Right? And a lot of times we'll write that as just 4x. Right? So that's part of the area. So we'll call this kind of the red area. And then I have this other section of the shape. Right? This is a complex shape. It's made up of a rectangle, and you might think of it as made up of a rectangle as well as a triangle. Right? Or maybe you see 2 triangles there. I'm going to go ahead and call it one entire triangle. Okay, so there's my triangle. I did cover up an important piece. If you remember, the area of a triangle is found by taking 1/2 the base times the height. So in this case, the triangle is labeled with a height of 3. The base isn't really labeled, but we can say, well, this part measures x. And so this part, which would be the base of the triangle, also must measure x. All right, so the area of that triangle then is going to be, an expression at least, would be 1/2 the base, right, 1/2 of x times 3. Or we might write that as 3/2 x. All right, so our equation on exploration 2, at least for shape A, is going to look like, okay, so there's our perimeter. I'm going to go ahead and simplify this. 2 times 4 is 8, 2 times 5 is 10, plus I have the x. So I've got 8 plus 10, so I've got 18 plus x is going to equal 3/2 x. Right? And then from there, we're going to use our examples if we need to. We've got a couple of minutes. I'm going to go ahead and step through solving this equation. So a way to solve equations with variables on both sides is to get the variables on the same side. So I'm going to apply the inverse operation of adding x to both sides of the equation, which is subtracting x. And then I'll end up with 18 is equal to, let's see here, 3/2 minus 1 would leave us with 1/2. So 1/2 x. And then the inverse of 1/2 times x would be to divide. So I have x is equal to 18 divided by 1/2, which in the end is 36. Well, I hope this helps you get started in terms of perimeter and area. Remember, if you can at least get through exploration 1 and 2A, I think you can do 2B. And if C is too much of a struggle, you're running out of time, you might just jump on down to exercises 3 and 4. So thanks. I hope this helps. Remember, math is cool, and so are you.